Hello, statistics student. This video is for chapter 12.1, 12.3, and 12.5. Linear equation, regression equation, and prediction. So build up some basic understanding of what we're going to do now. We have seen that a pair of data has some linear correlation. It could be positive, it could be negative. There's some upward trend or downward trend. So the next step is trying to extract that lines that might go through all the points, right? So last time we say, oh, we see these points, they seems to line up in a certain way, but they are not totally in a line. So we want to, oh gosh, this is not very, how come it doesn't go through that? So it doesn't it doesn't work this one. Okay, so that is the scatter plot that we have, right, between X and Y, but they don't line up really well. So our goal is to see if we can find this line that can pass through them, and then maybe we can use it for prediction. So first of all, is to some background information of what is a line equation. If we have two variables, X and Y, that's the match pair data. Then if you graph the points and the equation of a line is always y equal to a plus bx. Y equal to a plus bx. If you graph this, it would be in the form of a line. And, you might remember that in algebra, they don't write it this way. They would write y equal to mx plus b. But in statistics, usually they write the y-intercept first. And well, actually, some books do a plus bx. Other books do the software, the statistics software do y equal to b0 plus b1x. Okay, but you will see that there the equation in general is y equal to something, and you have a constant term and a x term. If you graph it, it becomes a line. X is called X is the independent variable because you plug in here for X to find Y, and Y is called a dependent variable. And in statistics, we also call it the explanatory variable. It is Y is the explanatory variable, X is the predictor variable. You use it to predict. You use X to predict Y. The goal is to use X to predict Y, so that's why the equation is Y equal. So if you are a line, you have an upward trend and you have a line like this, then your B, in this case the B which is the coefficient that multiplied to X, is positive. Then we say it has a positive slope, which is like graph A. If it is less than, if B is less than, then the graph has a negative slope, like graph C. And if B is 0, the line has a horizontal slope. It's just a horizontal line that corresponds to no correlation. And the value of A, which is a number in the front, is called the y-intercept. It is the value when x is equal to 1. Okay, sometimes we call it the initial value. So basically, you graph it, you would see a point A 0, comma A here, because when x is 0, it's A, and then this, if B is positive, right? And if it's negative, you will see a 0, comma A here, and then it goes down if B is negative. So how does it use in general to model anything? So for example, if you're ordering stuff, you order X books or X t-shirts, which has a cost per item. But if you order them, then you have a fixed shipping cost of $4.99. So the total cost would be, you would know that the total cost is you have to pay the $4.99 plus 3.2 times X, right? If X is 1, you would say 3.2 times 1. If you order 5 items, then it's 3.2 times 5. So this would look like a linear equation. And we call this slope 3.2. Why? Because it's a cost. So this is cost, right? Total cost. It's the cost per item. X is X is number of item. So we call it the slope if it is multiplied to X. And it is also a rate of change. is the change of y, how much cost it is per change of x per item. Okay, the y-intercept is 499. That's the number that doesn't have x values. It is the cost when 0 items are ordered. Now, in this case, it's not meaningful. If you don't order anything, if you order x, you don't need to pay 499, right? But theoretically, when x is 0, you pay 499. Okay, but it's not meaningful in real life. So let's go back to look at regression equation. So if we want to find the equation that pass through or is close to all the points, so that we can call it the trend line, right? So, and sometimes we call it the best fit line, sometimes we call it the least square line, sometimes we call it the linear regression line. So this books we use the linear regression a little bit more. So how do I calculate this a linear regression line if all I have is those points, because they don't line up totally, right? So what is the best one? So first of all, you have to identify which one is x, which one is y. So remember, the general idea is you use x to predict y. So if you have x and y, you say, okay, maybe the shoe size can predict math scores. So your x would be the shoe size, y would be the math score, right? If you say exercise can predict or can influence your blood pressure, then x, it will be the exercise hours, and then blood pressure is your predictor variable, dependent variable. And in a statistic, the line of best fit is not y equal, it's y hat, y with a cap, okay, with a cap like that. So it's called y hat equal b0 plus b1x. b0 is the y-intercept, b1 is the slope. The slope is the number that get multiplied to x because it changed when x changed. So it is the rate of change of y per change of x. So it is y hat is called the predicted y, to differentiate it from the original observed y. Okay, y is the observed value, y hat is the predicted value. So so this is like the terms and also the notation. Now, how do I calculate them? And also, which one is the best? So can I just write something? Okay, so there's something that I need to talk about. I'll come back to coefficient of determination. It is related to our linear line. It describes how good the line is. So first, just a little bit concept on how to determine the line of best fit. What's the theory behind how do they choose it that it's the best? So basically, they will you can just graph a line, and this line will give you a predicted y, right? So this number is what you will predict. We call it y hat, and this is the observed one. If you have the same x, right? X is here, x would corresponds to what you observe here, and so the residual epsilon is y minus y hat. What is the difference between the observed and the prediction? And the best fit line is the line where the sum of square of all these small differences, so vertical differences, so this is a small vertical differences, square them, add them together, the best fit line would have all these sum of differences the least. It's the smallest sum of sum of square residuals is the smallest possible. So calculus are used to build this so that you know that there is only one line. And it turns out that this line also always pass through x bar and y bar. So the of course, we're not going to calculate by hand. We understand how it was being calculated. So to do it, you would do set this. So, and then analysis, correlation and coefficient, that's the only thing you do, right? So let's say child size, shoe size, and math score, because last time we said that they have linear correlations, right? Shoe size, math score, evaluate. So we don't look at correlation. We look at correlation in the last video. So we confirm that they have correlation because 0.02218 is less than p-value. Now we look at the regression result. So this is the regression line. They say y, okay, because I think it's very hard to print y hat. But when you copy it down, please write down y hat. So what you do is you copy down B0, which is here. The first number is 3.861. And then B1 is 8.474. Round to 3 decimal places in all these. And then the third one that you want to copy down is the one that I skipped, is the coefficient of determination, R square, 0.767. So these are the 3 things that is useful. So let's go back to our notes. Right, so you copy down y hat. So when you copy it down y hat, copy down B0, B1, and also R square. I should write down that you should copy R squared also. And then this is the good time to talk about what is R square. So R square shows you the proportion of variation of y that can be predicted by the change of x. So that it actually tells you how good the linear prediction is. So, and usually written in percentage. Okay, so let's look at an example. We have the shoe size and score. That's what we did. So we write down 3.861. B1 is 8.474. R square is 0.767, or change into percent, 76%. So how do we interpret this whole thing? We would say y hat is equal to 3.861 plus 8.474x is the linear regression line that relate child's shoe size and score. And this is the slope. It tells us that the score, y is the score, will increase 8.5 points for every increase in shoe size. It's very strange, right? It's the slope is change of y over change of x. It would increase that many points, math points, if your shoe size increased by 1. Correlation coefficient we also written down is 7.6%. It means the 76% of the variation in math score, the change in math score, are predicted by the variation in shoe size by this linear equation. So this linear equation is good for 70.6% of the change of y. Okay, so that's it. So you just run the regression correlation, you would have that. So the next video is about prediction. So now that you find your linear regression line, you can use it to predict y for a given x. So we'll do this in the next video.